Hello guys and welcome. In this lecture we will see the Canny Edge Detection and how we can use it in OpenCV. This algorithm is a popular algorithm in OpenCV and it has 4 stages. The first one is the noise reduction where it uses the Gaussian filter to smooth the image, and then it's apply the Sobel to find the image gradients, and then it applies the no maximum suppression to remove the unwanted pixels, and finally it applies the thresholding to get the edges of the final image. So let's see it in practice with OpenCV. First I will create a Python file. I will call it Canny Edge Detection .py. I will import CV2 and numpy, and then I need to read an image from the data folder here. So I will read image equals cv2.imread. I will give it the path data and I will read messy image. I will read it as grayscale, and then I will show it here cv.imshow original and giving it this image, and then cv2.weightkey 0. Let's run the code and see this image, Canny Edge. So this is the original image that will work on. So first I will call the resulted image edges, and I will call cv2.canny this function, and I will give it the image, and then I will give it the threshold 1 and the threshold 2. So these are for example, let's give it 100 and 200. We can change this later, and then I will show here imshow edges and then call the edges here. Let's run the code also. So this is the edges of this image detected by the Canny algorithm. We can change these values. For example, if I give it 127 and 155, let's see the result here. So as you can see, this is the resulted image. You can create, for example, a track bar to change these two values and see the results in real time. So if I apply this in another image, let's for example apply on the Einstein image and see here the result. So this is the edges detected and this is the original image. If I apply it also on another image, I have here dogs or dog. As you can see here, this is the edges detected. I can also apply it on any image. For example, if I apply it on cards image, show it here. So this edges detected by this algorithm. Let me change this back to messy image. So if I messy image and if I show the image here, so as you can see in this image we have many edges here that we don't want. So we don't want this edge here and this one here and also this line here. We are interested just on the messy image, the person image here, the football image here, and this logo here. So for get rid of this noisy edges here, we can reduce, or you can blur this image to make the Canny Edge Detection algorithm detect just the edges that we want to detect, like the person here and the football or the soccer here and also the logo here. So let me blur this image and apply Canny Edge Detection on it and see the results. If I come here and create an image blur and using CV2 dots, you can use any blurring method like the bilateral filter or the blur or the Gaussian. If I, for example, use the Gaussian blurring, the Gaussian blur giving it this image and the kernel size as, for example, 3 and 3. We can adjust this later, and the sigma as 0. Let me show this image here. So now we should make the Canny Edge on this blurring image, so blur, and then running the code, and as you can see we get rid of many edges here, but we're still detecting this edge here and these ones here and these lines here. So if I make this bigger, make this kernel bigger, we're still getting this noisy edges here. So if I change, for example, this to 1, this sigma to 1, and as you can see we still have these unwanted edges. If I make this, for example, bigger kernel, so we still have these edges. If I, for example, make this 2, so now we lost everything. So if I turn this to 5 and 5 and keep the sigma as 2, so now it's better. We didn't have this unwanted edges, but this image also is still or these edges also still bad. So if I return this to 3 and 3, so we get this one. If I, for example, remove this 5, but if I adjust this kernel size here, for example, make this 100 and this 200, for example, yeah, we still have these edges. So if I make it like, for example, 120, we can try another type of blurring, for example, the normal blurring. I will use the same kernel size and we still have the same. If I use, for example, medium blurring, here we can give it 5. So now it detects more edges. If I make this, for example, 7, it's still noisy, and with 9, I'm sorry. Or if I, for example, try bilateral filter, make this as 9 and 75, and if I make this, for example, 100 and 100, so now it's better. I think the problem is coming from here. So if I make this 150 and this 150, 255, so now it's good. You can, of course, adjust these values, the value of the blurring and also the value of the thresholds here in the Canny. You can create track bars to change these values and getting better results than these ones. If I apply it on, for example, Einstein image, let's see it here. So this is Einstein image. Of course, it's very bad. If I change this to 7 and keep this as 75 and 75 here, now it's better, but we're still able to make it better. If I change this to 120 and this 200, you can also try it with Sodico image.
sudoku image. Oh yeah, it's here, it's losing lots. Make for example 70. So we can work on this blurring parameters here or variables here, and also the Canny variables here to get better results.